It's everyone's favorite game show. What dimension are you? The exciting new game show where you can win fabulous prizes. All right, maybe there's no fabulous prizes, but you can review for a formative and a test and test your knowledge of the dimensions of some geometric figures. So here are pictures of some of them. We'll reference this as we go through the list. And here are all the terms that we want to put in the right spot. And they're all mixed up. All right? So let's just begin. We'll go right to left, top to bottom. There we go. It's a crazy little mark there. So we'll start with this one. Polyhedrons, which are the prisms and pyramids. And we can go back and look at a picture of those. And down at the bottom, I only put a pyramid in here. But the pyramid, actually there's a prism over here. So this one is a prism. I actually use that. I'm using that for something else. But that's a prism, singular. And here we have a pyramid. And you can see they are made of several faces. Right? Both of them actually have 6. Because we have a pentagonal pyramid and we have a rectangular prism. Could be a cube, right? But a cube is a type of rectangular prism. And we can see that they have length, they have width, they have depth. How many dimensions would that be? All right, well, you think in your head, all right, how many dimensions it is, and see if you can get it before I get there. Dun 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 dun. Whoops, it's off the screen now. It has 3 dimensions. So polyhedron are 3 dimensions. Skew lines. So skew lines are 2 lines that do not intersect because they do not lie in the same plane. So I can draw on the prism there some skew lines. So for instance, DC and BF are skew lines. Now it might look like they are intersecting. I'll even choose a different line just to make sure. But they're not intersecting. That's just because I'm writing on a 2-dimensional board. One is behind the other. But how about if I choose this one over here? All right, you can see there is no way that these are going to intersect. They are in 2 different planes. Right? So we've got 2 different planes. How many dimensions will that be? Let's see if you can figure it out before I get there. Dun 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 dun. Dun 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 dun. 3 dimensions. Skew lines are 3 dimensions. We have all 3-dimensional things on one side. Non-collinear points. Well, collinear points make a line. I was covering up some red there. Looks like my white moved around a bit. Pretend it's not there. Anyway, let's get back to where we're going. Collinear points are all in a line. Non-collinear points are not in a line, right? We could not possibly connect those with a single line. All right, so how many dimensions is that? All right, you think in your head, how many dimensions? Before I get there, oops, no. I just want to move them. Come on. Dun 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 dun. Which way am I going? Dun 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 dun. 2 dimensions. Non-collinear points are 2 dimensions. An arc. That's kind of tricky, you know. Let's take a look at a circle. So here we have a circle. The arc is just the outside of the circle. It's curved, but we could straighten it out, right? And if we straighten out that arc, what do we have? We have how many dimensions? Let's see if you can figure it out. It is one dimension. So the arc is one dimension. Perimeter. Right? So perimeter, we are measuring the outside of something. We call it perimeter if it's a polygon. We call it circumference if it's a circle, but it's the same thing. We're just measuring the outside distance. We're not measuring the inside part. So how many dimensions is perimeter? You think of it. Dun, 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 dun. Also one dimension, right? Because if you were measuring an arc, the length of an arc, that's perimeter as well. Collinear points. Well, non-collinear points were 2 dimensions, right? And if we look at our diagram here, collinear points, they form a line. How many dimensions is that going to be? Dun 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 dun. One dimension. I'll go faster when I think you know it. Volume. Volume is, oops, wrong way. We don't want to see that. I made it look from icky to pretty. Volume is we're measuring the amount of stuff inside a three-dimensional object, like a cylinder or a pyramid or a prism. Right? So if we're measuring the amount of stuff, then volume is going to be, and we're measuring the amount of stuff inside a three-dimensional object, that is going to be 3 dimensions as well. So volume is 3 dimensions. Oh, I didn't sing for you. Parallel lines. Right? So here we have an example of parallel lines. UY and AW are parallel lines. Could have drawn my skew lines on that one too. And so notice that parallel lines can be connected by one plane. So how many dimensions are parallel lines? Parallel lines are 2 dimensions. Oh, by the way, I almost forgot to tell you, but it says it in the instructions for the Nearpod. Don't forget to write these down in your notes. So you should still have a place in your notes that says 0 dimension, 1 dimension, 2 dimension, 3 dimension. Guess what you're putting in there? All of these words. Okay, so the words go in the blanks. You don't have to draw a picture. The other spaces, you can just use them if you need extra space to write the figures in. But you don't need to fill anything else out unless there'd be something that would help you. So if I say something that would help you, then write that down. But otherwise, don't worry about it. All right, just make sure you have the terms. Opposite rays. All right, so let's take a look at some opposite rays. We have some opposite rays somewhere. Well, I'm going to take the collinear point and let's just say that's point A. All right, and ooh, let's be point B. So, sorry, the line is very crooked. It's a little glitch in the board. So there's line AB. I mean line AB. Oh my goodness, ray AB, and we'll call that point D. This is, oops, we're using the letters bad because the board is being bad. All right, and there we have ray AD. All right, and those are opposite rays. They share an endpoint. They go in opposite directions. They do not overlap, and they create a line. So now you think, how many dimensions is the opposite rays? See if you get there before I do. Dun, dun, oops. I guess if I stay on the thing too long, that pops up. Dun, dun, which way am I going? Dun, 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 dun. Back to 1 dimension. So those are 1 dimension. Polygon. So polygons are figures. They're a closed figure comprised of line segments. So the circle is not a polygon, but the hexagon here, this is a hexagon. This is actually a regular hexagon. So regular would mean it has all the sides and all the angles are congruent. It has 6 congruent sides, 6 congruent angles. But it is a hexagon, and a hexagon is a polygon, right? And we can see that that polygon would be how many dimensions? Oops. That's going to keep doing that, isn't it? Dun 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 dun. 2 dimensions. A line. Well, opposite rays. It's going to drive me crazy. Opposite rays make a line, and they're 1 dimension. Guess where the line goes? 1 dimension as well. Straight angle. So a straight angle. Let's actually look at our angles. So a straight angle is right here. All right, and we can see it is 1 dimension, right? You can kind of think of the turn here, and that kind of seems like it's more, but it really is just 1 dimension because we're looking at the object. So straight angle is different than the other angles, belongs in 1 dimension. A circle. Well, a circle's kind of like a polygon, except it's curved, and it's going to go dun 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 into under 2 dimensions. Now we're up to non-polyhedron, the sphere, the cylinder, the cone. I think I have a cylinder over here. Notice, in a lot of ways, it is like the pyramid, except it is curved. So the only difference between polyhedron and non-polyhedron is non-polyhedron have curved edges, and non-polyhedron go into which way? Dun 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 under 3 dimension. Intersecting lines. All right, so we know what one line is 1 dimension. If they intersect, I think I've got intersecting lines over here somewhere. Well, we've got intersecting lines all over the place, right? So if we look at, for instance, DC here, so, and I'm marking in the color DC, which is already highlighted, and BC. All right, so notice we've got 2 dimensions. We are naming a plane. And so intersecting lines, just like the plane, I guess I'll put him up there too, are 2 dimensions. How about perpendicular lines? Does it matter how they intersect? No, that also goes into 2 dimensions. Matter of fact, every line relationship, we may as well move the other one. What happened to pair? Oh, he's already up there. Pair lines is already up there. Every line relationship, parallel, perpendicular, or intersecting, they are all 2 dimensions. The only one that's not, the only line relationship that's not 2 dimensions is the skew lines, because we're involving more than one plane. Polygon. Oh, he's on there twice. What the heck? Goodbye, polygon. Oops, I guess I can't get rid of him. It goes too fast. Ah. Here, I'll move to the computer and we'll get rid of the polygon because he's on there twice. He's gone. There we go. All right, coplanar points. Well, coplanar points are points that are on a plane. So 2 dimensions. A ray. All right, so let's look at the ray. All right, so a ray is part of a line. It has an endpoint. Here we have the ray. And it continues in one direction. This particular ray is ray GH. The G has to come first because that's the endpoint, and that's the symbol for ray, and that is 1 dimension. So let's move the ray under the 1 dimension. Do, 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 do. A point. A point doesn't have any dimensions. Do, 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 do. So the point, as you can see here, it's just a location. It has no dimension at all. We draw a dot because we have to draw something. We can't draw nothing, right? It'd be hard for us to say there without something to point to. Solid. Well, so polyhedron and non-polyhedron are types of solids. The solid is three-dimensional. Line segment is part of a line, so if a line is one dimension, so is a line segment. Non-coplanar points. Coplanar points are two dimensions. If we're non-coplanar, like for instance, if we look back at the diagram here, so we'll use this one. So U, Y, A, and E, for instance. Those are non-coplanar. My plane would have to turn, and planes don't turn, right? So once we involve more than one plane, that is going to be three dimensions. So coplanar points, two dimensions, non-coplanar, three dimensions. And collinear lines, collinear points, one dimension, non-collinear points is going to be two dimensions, right? So as soon as we aren't all in a pretty line or all in a plane, we're going to increase the dimension. A vertex is just a point where two rays meet to form an angle. So vertex is 0 dimensions. It's just a type of point. As is a point of intersection. It's just a point where two lines intersect, but it's still just a point. Volume is 3 dimensions. Perimeter is 1 dimension. Area is 2 dimensions. All the angles besides the straight angle are 2 dimensions, because they're not in a nice straight line. So our other angles here, here's the acute, the right, the obtuse, and here we can get the other one, a reflex. Those are all 2 dimensions. And then the last thing, intersection of planes. Planes intersect, oh, I think I had a picture. Planes intersect, and you can see it there. So we have this green plane here, UYA, is intersecting, for instance, plane BXW, right, at line AY, right? So planes intersect in a line, and a line is 1 dimensional, and ta-da! There we go! So we have named all of the figures. What's my dimension? Our game show is complete. Congratulations. You get a year's supply of rice-a-roni, the San Francisco treat, and some turtle wax. Thanks for playing. Bye for now.